Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everybody. Welcome to International Undergraduate Program for the courses Probability Theory. So for these classes, we would like to discuss a lot about probability theory. So my name is Ahmad Fairuddin from the Department of Statistics, Institute of Technology, School of November. Before we go into further, so I would like to introduce myself. So this is actually my background. So I started my bachelor SU as a statistics student in Institute of Technology, School of November, and then I goes for a master degree in France in Aix-Marseille University. I come as a research assistant in biostatistics, and then I did my PhD in University of Grenoble in France, and then I did a postdoc in Aalborg University in Denmark, and then afterwards I came back here as a senior lecturer in the Department of Statistics. So I hope that after this one, I would like to stay motivated to you, so that after this one, probably you can go abroad, and I think that we have a lot of probability or possibilities. Okay, for the probability theory class, we have 16 minutes, which is divided into some classes or some minutes. The first one, which is about the introduction to probability theory, we will discuss about set, random experiment, sample space, event, sample point, and field. And we discuss this one in the first 2 weeks. Next, on the week 3, we are going to discuss about the definitions of probability, and then there are some rules, which is addition rules, conditional probability, and also the concept of independence. In the week 4, we are going to discuss the product rule, probability, total probability, and also Bayes rank. And then in the week 5, we're going to have tests for the first 4 minutes. The next one, on the week 6 and week 7, we are going to discuss the definitions of random variable and also the probability distributions of random variable, which is the definitions and the characteristics. The next one, on the week 7, we are going to discuss conjoint probability distribution, and then on the week 8, we are going to have the midterm exam. Okay, next one, after the midterm exam, we are going to have some discrete distribution and also some continuous distribution on week 9 and also week 10, which includes binomial, hypergeometric distribution, geometric, negative binomial, Poisson, and then for some continuous distribution, we learn about uniform, normal, exponential, gamma, and also log distribution. The next one about mathematical expectation, we are going to discuss about expectation variance and generating function in week 11 and 12, and then we're going to have tests on week 13. The next one, before the final exam on week 16, we are going to discuss on the 2 weeks on week 14 and week 15 about the expectation and the variance of some well-known distribution that we discussed on the week 9 and week 10, which means that we are going to discuss what is the expectations of binomial distribution, expectations of geometric distribution, expectation and variance of normal distribution, and etc. And also the moment generating functions as well. And the next, on the last meeting before the final exam, we are going to discuss some type of convergence, including semi-certain inequality, convergence in probability, convergence in distribution, and also convergence almost surely. And the next one, we have the final exam. And actually, for these courses, there will be 2 lectures that will give you this one. The first one is me, and then the next one will be continued by Professor Mateo from University of Jaime, Spain, will come here in US. Great. Any questions? Is that clear enough? Okay, great. And then the next one about the reference. I would propose to you these 5 references that you can do to understand a little bit more about the probability theory, especially the one that I have read, which is written by Undergraduate on 1995, or the newest one in the 8th edition on 2018, and then this one is by Walpole et al. That is written in 2012 about probability and statistics for engineering and natural sciences. Great. next one about evaluation. So this is my proposal so that you can give some comments or remarks or any questions. So there will be 5 different evaluations. So the first one is about practical session in a class. We have a mini test, we have a mini project as well, and also we have a homework that we will conduct during week 1 and week 16. Of course, it is not in every week we're going to have this one, but at some weeks we're going to have this one that we can also do as evaluation. And the percentage should be 10% of that. And then next we have a test on the week 5, which the percentage is 20%, which is equal to the midterm exam, which is equal to 20%. And then the next one we have 2 evaluation. The second test on the evaluation 3 on week 15, which is 25%, and the final exam is 25%. Okay? Probably you have any question?
Sir.
Yes, please.
Pardon me, I know what is the difference between mini test and test.
Okay, alright. So the difference between practice, mini test, homework, and actually I missed one point as well, which is I call that a mini project. So what is the difference? So the practical session, so meaning that I will give you some exercises and then you will do that in a class, probably with some help from me or without my help, and then we will discuss in the class and then we know already what is the answer of that one. And then we have also a mini test and a mini project. The difference is that for a mini test, it is because it's a mini test, it's a small test, so the duration probably around 10 minutes or less than that. I will give you a mini evaluation to know what you understand about what we already just discussed. Okay? This is conducted individually, but for the mini project, it is also about the test as well, or a project. So I will give you some problems or some issues, and then you need to solve that problem, but in team. It can be in team of 2, team of 3, team of more students. For the homework, because it is homework, so it means that you have a problem, but you need to solve that at home outside of the class, and then we can probably discuss that during the class in the next session, or probably in the outside of the class session. Is that clear enough? Yeah, or do you have any questions?
Yeah, it's clear enough.
Okay, great. Any other questions? Good? Okay, great. So if there is no more questions, so I think that I'm going to continue or start this session about the probability theory. And for this 2 meetings, we are going to discuss about introduction to probability theory. My question is, what is probability theory? And to discuss that, we are going to have these 4 topics. The first one is introduction to probability theory. We're going to discuss about set and experiment. And then we also discuss about sample space and sample points. And then afterwards, we're going to have also to discuss inference and event diagram. And then the next session, we're going to play it. So, what is probability theory? So basically, probability theory is a branch of mathematics that investigate the probabilities associated with the random events. And probability theory describes the chance of occurrence of an event. So suppose that actually right here, I would like to know what is the probability if I pick one student from, for example, here we have 9 students, and then I want to pick without knowing, for example, like this one, I pick one student in the second row in the 3rd column. So it means that 1, 2, 3, that's one. So the sex of that student, which is the female, like that one. So I want to know what is the chance that I can get if I do not look at the students, what is the sex of the students that I pick. It can be female, it can be male. Okay, so that is something like the probability theory. And the origin of the probability theory lies in physical observation associated with the games of chance. That is usually depend more on luck than skill. There are some other examples of probability about the reality of the probability theory. The first one is that I gave you already. Do you have any other like examples? For example, about probability theory? Yeah, Vicky?
The chance of winning and losing a game
chance of winning or losing a game, good. Chance of probably winning, yeah. If winning or losing, so both, so the chance would be 1. Winning a game. Great. Any other question? Any other opinion? Asacha?
Is the chance of rolling a die?
Roll a die. Good. The chance of probably getting, say, 6 of rolling a die, right? Because actually, if you have a die, so you have 6 sides, which is from 1 to 6. So you want to know what is the chance to get 1, 2, 3, etc. For example, here is getting 6. Great. Next one, probably one more. Yes, Hasan?
A chance of getting a red card from a deck of cards.
Okay, chance of getting rid of cards from a deck of cards. Great. So, of course, that actually a deck of cards, there are a number of cards, and then we would like to know what is the chance to get one of them, for example, here is red of cards. Red of card. Great. For this one, so you know that actually there are some examples about that, and some of them that you already do, like a card game, rolling a die, or tossing a coin, because actually the probability theory comes from this game of chance. And actually, if you see this movie, so this is a movie quite old enough, in 2008. The title is 21. So this is basically actually the students from Harvard University. They do kind of a club, like for example, like this one, 9 students. You do math together, and then on weekend you do a game on a casino to win like the game. And there are a lot other as well examples of probability. So for example, in the election, what is the probability if I were to go on the election, the probability of winning. And then for example, the in the mechanics, the probability, the maintenance of machine, and then the next one probably about the cross factorization on the biology if you cross different types of plants or flowers and etc. Probably one more. What do you think? Outside of tossing a coin, rolling a die, card game, and then there are some other applications in politics, mechanics, biology, etc. Yes? Okay.
The chance of getting wrong someone else.
Could you go?
The chance of getting dumb. If you ask someone else.
The chance of getting
Dumb.
what?
Dumb.
Ah. Of asking someone out. Yes, of course. For example, Lutfia asked Maya out, and then there will be always a chance of he rejects or accepts that invitation. Okay, great. So I think that we can go on the next session. So this will be about the definitions of set and then an object. So suppose that actually we have a set which is defined as a collection of objects that is basically we denote by curly bracket. So for example, A defines the first 5 positive integers, so it means that A includes 1, 2, 3, 4, and 5, and we cover that with curly bracket. Okay? And then for example here also the set is other one, but the numbers 3 over 4 or 14 are not the set because it is just a member. And then the number 3 over 4 and 14 is outside of this set, but the number 3 is inside the set because we can see we have an object. So object is basically the element of a set. For example, like this one, 3 is an object of the set A, but 3 over 4 and 14 are not the object in the set A. Okay? And you can have another examples about that. For example, C is a set which is a real numbers from 0 and 1. So we can see that actually 3 over 4 is inside or outside? Inside. Because actually 3 over 4 is between 0 and 1, right? But suppose that actually I want to see if 4 over 3 is it inside or outside? Outside, because 4 over 3 is greater than 1. So it means that 4 over 3 is not a member or is not an element of this set which is we define between 0 and 1. And we denote if a member or an object here is an element of a set, so it means that C, which is in our case is 3 over 4, is element, which is denoted by this one, of the C, where C is equal to any set from 0 to 1. Is that clear enough?
Yes.
Okay.